Hello, guys. Welcome to Houdini 16 Amarok, the launch event here live at the Rich Mix in London. We are going to take about 10 minutes because there are still quite a few people filing in. We had a long lineup outside, and people sat through or stood through the rain, and it was cold, and we want to make sure that they get inside and seated in the warm place in here with all of us. So if you're on the internet, give us 10 minutes. We're going to start at 10 minutes after whatever hour it is now in your location. Okay? Talk to you soon. And for the people up on the mezzanine, you're going to want to be in the cinema that you've been assigned to at least before 10 minutes after. Okay? Thanks, guys. Talk to you soon.
Hi everyone, I'm Kim Davidson, the President and CEO of SideFX, and I'm delighted to be kicking off our Houdini 16 launch. We're really excited to be showing you all these updates to Houdini here at the Rich Mix in London and I guess globally streaming around the world. We're going to have some product demonstrations later, and our VP of Product Development, Kristen Bargill, will be up to show you that. But before that, I just want to speak a little bit about our company, our customers, and the Houdini product, myself, from the founder, co-founder viewpoint. One of the core concepts of Houdini is this idea of proceduralism. And this idea goes back many years. It was in Houdini, it was in the predecessor, Prisms. And it actually started before SideFX started at a company called Omnibus where I was writing Prisms. And we bought the software from Omnibus when they went bankrupt. Now those were the days of mainframe computers and dumb terminals and no graphics cards. So Prisms began as a series of text commands, and the idea was that you'd write a command that took one or more file inputs, did a discrete operation like extruding 2D polygons into 3D text and then outputting a file. And when you gave these text commands variables, parameters, and arguments and strung them together, you got a powerful paradigm, and we called this procedural animation. And that procedural animation, for those who are actually new to Houdini, is pretty powerful stuff. It's good for very fast prototyping. It's great when the client changes a decision. You can just reiterate the pipeline by changing one of the values. And it's also very good for representing a very compact representation of a very complex and potentially very large piece of geometry. So that's a powerful paradigm, and that's served us very well for many, many years. But I think proceduralism is never more relevant than it has been today, because you all have to create like bigger and bigger worlds and more shots. You have to create a lot of these. You have to do that fast. You have to do that at high quality, whether you're in TV or film or VR or games. It's all want that high film-like quality, and more artists are turning to Houdini for that, and Houdini proceduralism to get that quality in those big worlds. Now, we're turned 30 years in June of this year, so we've been around 30 years, and for a tech company, that's quite an amazing achievement. And then for one that serves this artistic community that's always changing and very demanding, I think that's incredible. And when I look back, when I was there at the start, I didn't really think, whether we'd be around in 30 years. But looking back, I'm actually not that amazed, because we have this incredible team of an innovative team of developers and supporting team, and they synthesize all the technical changes and all the customer input, and they just keep Houdini on the cutting edge. It's a team that can innovate as fast as you all do. And so they've kept that Houdini very relevant as it is today. Now, Houdini is known, and I think with Houdini 16 we got probably the largest and most cutting edge release to date, and you'll see that later. I think, though, one thing I do want to mention, and you'll see it later today in the Houdini 16, is that Houdini's been known as the visual effects. It's known as the go-to to handle all the large visual effects, whether it's like large oceans, crumbling buildings, or erupting volcanoes. Houdini's kind of the go-to software. It handles the effects that interact with effects that interact with the environments. It processes lots of data. The simulations create lots of data. It handles lots of geometry. But Houdini's been used for more than effects. It's been used for modeling, for environment modeling, for animation, character effects, character animation, lighting and rendering. So we put significant improvements into the effects for sure. You'll see that. But we put very amazing improvements to other areas of the pipeline beyond VFX, if you like. So, take a look at that. Now, we've been innovating for 30 years. We hope to be doing this for 30 years more, because that's what I enjoy. So as long as the world keeps changing and you guys keep choosing Houdini, we hope to be using you, or working with you, for 30 more years. We don't want to use you. So on that note, let's get on with the show and get up some great speakers. And I'd like to welcome to the stage to give a product lineup and a few nice updates our Director of Marketing, Chris Hebert. Chris? Thank you.
Hey guys. Before we get to what we all want to see, which is Houdini 16 Amarok features, we want to take you through a quick summary of our commercial product line. So, let me scroll to the right page here. Starting with the foundational Houdini, which starting from today, going forward, we're going to call Houdini Core. Houdini Effects and Houdini Engine. So Houdini Core is great for modeling, rigging and animation, grooming, volumes, terrains, lighting, shading, rendering, and even compositing. It's a really solid tool that gives you most of the features in Houdini. Houdini Effects layers dynamics onto all those great core features. So you've got your pyro, your fluids, your particles, snow, sand, dust, crowds, RBD, and more. Houdini Engine. Let me just say on the effects side that keep in mind that anything that you create in effects can be used in either core or engine, right? So you create the assets and then you distribute them through core or engine. Houdini Engine provides two key features: plug-in functionality and batch computing. Engine lets you load Houdini digital assets into other DCC apps and game engines. So for example, you can have one or more technical artists creating those assets and then publishing them to the other artists in the studio. Engine also gives you command line access to Houdini's powerful node-based architecture price from today until May 31st. The offer. We think Core is a really fantastic product, and we want you to have another look at it because it is such a great tool for the studio to scale throughout the studio. The offer, there's no limit on the quantity, includes your first year of upgrades, or what we call AUP, so feel free to scale it up. And speaking of scaling up, we have some exciting news on rental pricing. Boom. So we've been hearing from you that it's important for you to have the flexibility to be able to scale up on temporary, projects come along, a big project comes along, and you want to add some licenses and artists to the studio, and then scale back down. So we have dropped permanently our rental pricing. So Houdini Core now rents for $19.95 a year, $255 a month, down from $1,000. And FX rents for $49.95 a year and $7.95 for the month, which is down from $2,800. So now this monthly for sure is now a viable option. It's not something that you need to use when you're desperate for a license and an artist, but something that you can use anytime. And while we're making these adjustments to the rental licenses to offer more flexibility, you can rest assured that perpetual licenses are going nowhere. We think that they're the best choice for long-term investment, but we do want to give you that flexibility in the short term. So that's it for the product update. On with the show, and let's find out all about Houdini 16 Amarok. To take us through that, I'd like to bring to the stage our VP of Product Development, Kristen Bargiel.
Hello, everyone, and thank you, Chris. Thank you, Kim. Great to see everybody tonight. We are enormously proud of the Houdini 16 release and really happy to be revealing it to you today. This is, like Kim said, the biggest release we've ever had. And this is not just in terms of number of features, there are lots of those, but also the scope, the breadth of it, which ultimately may be more important than just a feature count. What we're bringing into Houdini 16 encompasses almost every aspect of the CG pipeline. It starts with modeling and UVs, continues with animation rigging, muscles, as you'll see, big-time VFX, as you'd expect, and then lighting, rendering, even a little bit of compositing. So all of this coming together, and hopefully, those of you who are familiar with Houdini and use it for special effects will find it stronger than ever. But it's possible that it's the traditional modelers, the animators, the landscape artists, the game developers out there that might get the biggest kick out of it. And why? Because this is Houdini like you've never seen it before. Next slide, please. All right, so our main message to you is this. As we continue to increase the lead that we currently have in visual effects, we want to build a package that encompasses the broadest spectrum of 3D. A software that lets you create the same wild visual effects, bigger visual effects than ever before, and be technical about it in that case, as technical as it needs to be. But also a software that is friend to all artists, that is fluid, visual, and interactive. The key to succeeding at this, we believe, is obsessing equally over technology and the user experience. Sure, software development is inherently incremental, features mature over time. But we can tell you that these days, certainly with Houdini 16, there's no project, no Houdini feature that comes to life without a solid set of usability criteria set ahead of time and then validated early on in alpha and then finessed in beta. And this is how it's going to go forward. Next slide, please. Oh, okay. One up. And one more up. Okay. A key ingredient to making Houdini feel just as fresh and vibrant as it was when we launched it, what is it now, 21 years ago, is to look at the balance between architecture development and feature. So striking that right balance is key, and we strive to do that with every release. Houdini, first and foremost, is a platform. Yes, it comes with lots of features, but if the roots are not strong, if the branches are not strong, those features will ultimately dry up. Which is why it's very important for us to always focus on what makes the software as a platform really strong. We understand that importance. And thankfully, we are a privately owned company. We're in control of our destinies. So if there comes a time when we need to completely rip out an old module and replace it with something new, we'll do it. We won't hesitate it, and we'll take the time to do it right. And this is where Houdini 16, I think, shines most. It's in that respect. You know, it comes out only 9 months after Houdini 15.5, and yet it includes the largest number of fundamental changes to its architecture that we've ever put in the software before. So as we go through the highlights, please try to keep track of them. Let's see if you can count them. All right, so now we get with the next slide, if you don't mind. So contribute. Oh, okay. Just before we start the demo, I would like to take a moment to thank our R&D team, which is outstanding year in, year out. All amazing developers, each and every one of them. And our growing team of TDs who inject that invaluable production knowledge straight into the package. I also... Thank you. Also, a big shout out to our alpha and beta testers, a dedicated bunch and very patient with us. And also a big shout out to you guys for being here with us in the audience. Thank you. All right, now let's have fun with Houdini 16. All right, so we'll be covering these parts of the software in the next hour or so. And to do so, I'll be inviting 3 of my colleagues, 3 senior TDs. Scott Keating, standing right next to me. He is our usability expert, and despite starting in 2D, he took the plunge into 3D head first, was it, or feet first? I'm not sure, but he took it with Houdini, and he's doing amazingly, contributing a lot. Then we have Michael Goldfarb. He's developed a lot of the character tools that you'll be seeing. I think Michael started rigging before he could walk, he'll tell us. And finally, Kai Stavginski. And Kai is amazing at everything to do with 3D. He also has a great mind for usability, practicality, and a large software architecture, believe it or not. All right, so let's begin. I think the right way to start is to look at the user experience, because it's been a huge focus for us in Houdini 16. We were joking about this a while back, saying that even just what we did here could qualify as a good thing to have a major release with. So we've peppered Houdini 16 with usability enhancements throughout. There are small things and big things, but two definitely stand out. One of them is a brand new network editor, and the second one is an architecture for radial menus in the viewport. And there's no coincidence that we're doing these two things. This duality of network viewport, the synergy that it creates, is essential to any user of our software. So it's no accident that we went so hard after both of them in this release. Now, the network editor, the architecture that we had been in place now for 20 years. It was getting rather long in the tooth. And so we set out, like we always do. We scrapped it entirely, and we started anew. We have a brand new design. It's all written in Python and Qt, by the way. It was fun to do. And we set out with three goals. One of them, crazy performance with large networks. The second one, mad customizability. And the third one, just make it a joy to use. To demonstrate, go ahead, Scott.
I wasn't just here to push buttons while they were on the slides. Over the last couple of releases, we put focus on our modeling tools. We're sort of bringing them back up, making them really strong, and that continues in Houdini 16. So, sorry, the network editor. I was going right on to modeling. So let's start with the most obvious change, which is this ability to now have custom colors and node shapes in the network editor. And really the idea here is that we took a look at the old network editor and we realized that a problem was that there was no real way to understand your network just by looking at it. You actually had to zoom in, look at the parameters, look at the names of the nodes, and we wanted to give you some visual clues to help you along with that. And of course, if we're going to give you these clues, we want you to be able to customize that. So we have what we call a shape palette now, which allows you to just change the shapes of nodes by dragging and dropping. And there's a bunch of shapes to allow you to customize things, but also we have some standard shapes as well so that you can identify nodes right away. There's also the color picker, which now allows you to customize each piece of the palette using this new color editor. And the overview has gotten a overhaul as well, with now it represents the shapes directly in the overview, as well as the colors and any other kind of error states. And now if we're going to have you zoom out, we needed to add a tool to allow you to work on networks that are zoomed out this far. So we've added something that we call a node ring that basically lets you interact with the flags on a node even when they're zoomed out very far in the network. And so now, rather than having to constantly scroll and try and figure out where you are in your network, you can actually zoom out and get a nice overview and a real feel for what's happening in the network itself. And we've also added some interesting things to this. So now we can bring up a persistent info window instead of holding down the middle mouse button, which you can still do. And this persistent window can be pinned. You can copy and paste information from it, and you can have more than one info window open at a time. So you can actually compare the cook results, the memory, the number of points, and so on between these options. Another interesting thing about this persistent window is that you can type comments directly in the editor rather than going into a more obscure interface we had in the past. And you'll also notice that we get these little speech balloon icons under the nodes that have comments. Now these are something that we call node badges, and they're going to be used more and more in Houdini. For example, warnings. So you can see we have these two attributes. We're going to merge them together, and now we get a warning. And this little warning icon will show up in the info window, so you can copy and paste errors or warnings. But it also gives you an idea right from a high level of what's happening in your network. Same thing with errors. So if we just type some nonsense into this file node, you'll see we get errors now. And unlike previously, where we basically colored the node red, now we're giving you this large icon to really let you know that something is going on with your network. And this can become important when you think of very large networks, right? So let's just use the assemble SOP, which just has a bunch of nodes inside of it. And by the way, you'll see the lock here for a locked asset. And when we unlock it, we get this large unlock. Because, and again, in a production scenario, it's very important up to date or if it's unlocked. Put it onto the network. And along those tools to very quickly clean up their network on the part they're working on, and then move forward doing actual work, not the busy work of cleaning up nodes. Another important thing is that we wanted to very quickly. Another important thing that we noticed is people trying to avoid wires crossing through things. So we've now added the ability to create what we call these dot connections. And you get the error message here, and the node, the image comes with it. And so now building these networks that need to be documented and handed off to other artists becomes much more possible, a lot easier. Sticky notes have gotten a similar overhaul, but you know, so we can use them on existing wire and then pop back and forth very quickly. And then items in it, right? It's basically an overview of almost you want onto the radial menu. The shading options. Once you've used it, it's very, very difficult. I've had to do it going back to older versions. Yeah, I hope you really like it. Thank you very much.
Thank you, guys. Thank you, Scott. That's really nice. The machine gun, by the way, is entirely modeled in Houdini. Houdini 16, very clean geometry out of it. And the radial menus, yes, can be customized. So you can pop any tool in there, but also your favorite Python script. So really anything you want, you can do with them now. And talking about modeling, you wouldn't believe just how much demand we've been getting for modeling tools from everybody. Existing users, you guys in VFX, gamers, and also people from outside of the traditional Houdini community. So we're happy to tell you, confirm here, that we are committed to making the Houdini modeler a world-class modeler. This is going to be a multi-year effort, for sure. But expect in every Houdini release to see something significant related to modeling. And we'll have quite a few to show you in a couple of minutes. And it may be a step or a couple of steps or a big leap towards that goal. Now, the approach we're taking to this is looking at two things in tandem. One of them is strong algorithms for modeling, topology, UVs, you name it. And the other one, equally important, is the interactivity. So stuff you do in the viewport and handles and selections. It's not to stifle the workflow, to kill it for the sake of proceduralism. Okay. Scott, before we start, I do want to add one more thing. Because, we talk about math and algorithms, and I think it's worth saying one thing, that when we say we're reinventing our algorithms for sophisticated, computational geometry, we mean it. We don't just want to play catch-up. We want to set a bar in the industry. And if you take a look in a second now at our boolean tools and the destruction tool set that you can use with it, you'll know what I mean. So back to Scott. Thank you.
Okay, thank you, Kristen. So as I started to say before this slide, for modeling in Houdini 16, we really have gone back and taken a look at some older tools and either added new features or completely reworked them, especially when it comes to the Boolean. So let's take a look at something that used to be called polycap, and now we're calling polyfill. And part of the reason for that is that it's really not so much capping anymore. It actually can take these arbitrary holes in geometry and fill them with quads. So you hear them just cutting out random holes, selecting the edges, and then filling them in using polyfill. But it's not just quads. In fact, sometimes quads don't work out so well. But we have what we call triangle fans, quad fans, perfect quadrilateral grids like this, as well as the ability to add a nice supporting edge loop to the hole. But in some cases, that doesn't work, because like a sphere, we have no idea of the topology of the sphere. So we've also included some tools for shaping the patch that gets put in there so that you can match the geometry more cleanly. Especially in a shape like this where we have this really deformed kind of surface here. You can see that it kind of matches, but after a little bit of tweaking with the parameters, we can actually get it to almost perfectly match the surface of this sort of rubber toy here. Another tool that we've actually sort of just added some improvements to is polysplit. And this is very commonly used in modeling to do with things like edge loops. And typically what you get is something like this, where the edge doesn't line up to the edges on either side. But now with the new match profile tool, you can see we can actually make the edge loop match the closest edge, so you get a perfectly parallel edge to what you're doing, as well as doing multiple poly splits at once. And then just for fun, just to show how the modeling works with both our radial menus and some of the new right-click menus, you can very quickly take a poly split, extrude it, and bevel it. So again, just bridging the idea of placing nodes with working in the viewport. But sort of the 800-pound gorilla in the room is boolean. And so boolean is a complete rewrite of a boolean tool. It's not cookie. It doesn't use cookie at all. It's a brand new tool. And so it does, what you would kind of expect: union, subtract, intersect. You can see that we're correctly interpolating vertex attributes so that if you have a material or UVs on one object, you can boolean them together and preserve all of that information, which is very important. But of course, we wanted to kind of innovate here as well. So we also added something that we call shatter. And shatter basically allows you to take arbitrary cutting objects, in this case a grid, and use it to break up geometry into these slices, creating interior faces. And this is going to become sort of the basis of a destruction workflow. But again, Kristen talked about how robust these tools is, how complex the math is. And you can see here these boxes, which are all exactly the same size on the exact same plane. So all those faces are coplanar. They're exactly in the same place. But you can see on the right, where we sort of split them in half, how cleanly we interpolate this geometry, right? There's no flickering. There's no reversed faces. It's extremely clean, very robust, all because of that precision that Kristen talked about earlier. And then on the left, these green lines that you see here, these aren't just visualizations for this slide. Those are the actual visualizations that the node gives you. And these edges, what we call seam edges, can actually be exported by the node as groups. And so you can do interesting procedural modeling that's very difficult, like taking these three animated sort of widgets, cut them out, take those edges, and feed them into a bevel saw. And so now you can actually smoothly interpolate your cutting object into the surrounding surface using these edge seams. And of course, even in this sort of simple example, you can see, even though this is animated, even though we're changing the geometry significantly, you're not getting popping or sliding or any of those artifacts that you typically get from Boolean type operations. But let's take a look at a more heavy example. So these objects are very high-res geometry. The horse on the left is something like 250,000 polygons. The starfish are about 10,000 polygons apiece. And so Boolean is able to handle this very quickly, but also very robustly, because we're not just having one cutting object on A and one cutting object on B. We're able to have multiple cutting objects all at one time. So you see the union is being done not just with the horse and the starfish, but between the starfish themselves. Maybe a clearer example here is a subtract. So we're going to take the pig heads here and subtract them from the horse. And again, you can see how clean those edges are, how precisely we're cutting the pig out of the horse, and all that rich data that we're giving you for if you're going into a simulation or something after the operation. We're not cutting these things one at a time. This happens all at once in one cook. And let's just take a look at the result of this cutting. And so you can see here that we can manage this cutting no problem. And the interesting thing about this is that it gives you the ability now to completely art direct a shatter, right? Instead of having to sort of work with tools that are really great, things like Voronoi shatter, which are great tools. But a lot of times when you want to have a very specific look, you have to fight with the tool to get it. But now we're able to take this geometry, cut it up more or less arbitrarily, and get these very precise, accurate seams. So another thing that's really useful, kind of like exporting that line geometry, is that the Boolean tool can actually be used as sort of a way of analyzing meshes. So for instance, in this case, all we're doing, there's no Boolean happening at all. We simply asked it, where would an intersection occur if you gave these two pieces of geometry? And so we're able to feed that into a group, and in this case, we're just adding the color. And so this is sort of a neat, useful tool on its own, but if you imagine a more of a production scenario where you're getting a piece of geometry like this, and somebody says, okay, we need to smash this wall, we need to run a simulation on this. And the first thing you're going to do is go like, well, these pipes, they're just going through that wood, right? Like the modeler has just modeled, it looks good. Can't have no red on here when you're done. And that would work. That's a great way of handling. You feed it to somebody who's a very skilled modeler, and they'll clean up this lickety-split. But a better option would be actually to use our boolean itself to clean up these self-intersections. So we can take these errors now, we can use them to identify the self-intersections, and then automatically fix them. So here now is this wall split up, removing all of the self-intersections. So we've cut holes wherever a piece has intersected with another piece, so that now there are no self-intersections whatsoever in this geometry, which makes it very clean. It's ready to go now. You can start doing your actual work on it. And so the next step would probably, now it's all cleaned up, we need to shatter it and make it look good. So let's again take a look at a cutting object that we might use to break up this wall. So here's just an animation showing the pieces that we used. And this is a truly absurd cutting object. It's thousands of planes intersecting each other arbitrarily. You can see there's no real concern for whether they stick all the way through the geometry. We basically just threw insanity at it and said, what will this give us? And the answer is it will give us something really nice. We'll actually can break up this object. You can see how we can shatter the wood now and get a real splintered wood effect. And again, no longer fighting with this idea of like a Voronoi shatter or something like that, where you get these straight, hard edges. Now you can completely arc direct your shattering to look any way that you like. So here's just an example on the right of our new Boolean shatter, just compared to the Voronoi shatter. And they're both actually kind of cool simulations, but if you look at the Boolean, you can see how you get a sense for the material, right? Instead of this sort of generic, sort of a broken glass effect that Voronoi shattering gives you, you have this nice sort of splintered wood effect where you get a real feel that these things are not just breaking apart, but they're bending and shattering in ways that you would expect. And just to sort of drive that home, let's take a look at a sort of a close-up frozen moment. And you can see how the wood has not just these straight cuts in it, but these really believable wood breaking patterns. And the same thing with this sort of drywall, plastery kind of effect. Instead of this very sort of geometric look, you can have a real believable sense of like that material is different from the wood, which is different from the drywall, and it's different from the pipes. So these tools, like all together, I think, are starting to really give Houdini a really powerful procedural workflow for modeling that also is sort of artist friendly because we're working in the viewport, we're giving you these visualizations so you know exactly what's happening. So yeah, I hope you guys dig into these tools and have a lot of fun with them. So thank you very much.
Thank you, Scott. Maybe one thing to add or to explain is that the reason the Boolean math is so robust is that it uses exact predicates and exact arithmetic. It is a perfect tool in a numerically imperfect world, which may sound lowly and sad, but it's actually amazing. All right, let's continue. Character animation and rigging. Let me invite Michael to come on stage. Michael Goldfarb.
Hello.
Let me do a quick intro. So character work is another big passion of ours. You wouldn't think that, eh? From the big destruction particles company. Is that what people know about us? Well, we stand for a lot more than that. And one of the reasons we rebooted the work on character a couple of years ago was to respond to a community that was in dire need for a new home, looking for a fresh alternative to the existing status quo. But that's only one of the reasons. The other reason is that we're passionate about the entire CG pipeline, and we want to make it successful throughout that pipe, regardless of the department that you're in. So we started a couple of years ago, like I said, and we focused at first on renewing the animation tools. And this year is the big bang because it comes with an incredibly rich suite of rigging tools. Everything from capturing skin with nonlinear methods to auto rigs, Mr. Goldfarb here. Constraint system that is completely versatile. It uses chops, bringing chops to the 21st century and also into the viewport, artist friendly. And also a brand new architecture for muscle and flesh simulation that uses both all, as you choose. You can use springs or FEM. And we did a lot of work on our FEM solver for soft body dynamics that lets you embed bones and muscles and fat, basically things with arbitrary density into one volume, into one body with skin simulation as well. So I think it's best to show these things, don't you think?
Yes.
Maybe just one more thought. Of course, the muscles that use FEM use DOPS, they use dynamics. But you don't have to have Houdini effects to use them. You can use Houdini Core because the muscles come assembled by us as digital assets. So we do the authoring in Houdini effects, but anyone wanting to use the muscles that we offer and combine them and do all those fun things that Michael will show you, you could do that within that digital asset structure right in Houdini Core. All right.
Thank
Please,
you, Kristen.
Michael. Thank you.
Rigging is an exacting and tedious process, as the gray in my beard will attest. And so a lot of the work that we've been doing, especially for 16, is to reduce the amount of work that you have to do. Get to the thing that you need to do, that you want to do, that excites you, and that is to bring life to digital characters. And one of the fundamental things in rigging is deformation. And so I'm going to introduce what we call biharmonic weighting. And it uses a tetrahedralization, I got that out, of your mesh. And then, as Kristen alluded to, it uses a nonlinear skinning. So this is a little comparison. This was C regions, and this is default. I didn't attempt even to fix these things. This is right out of the box. And that's okay. This is what you would do 10 years ago. Lots of painting. It was improved with proximity. You can see that all the points are captured, but it's still pretty crunchy. There's a lot of work to be done here. Not anymore. Biharmonic capturing, default. I haven't touched this. It's wonderful. When I did this, and what I'm about to show you, I looked around the office for someone to tell, because I was so happy. And this made me smile. This is default. I haven't touched this at all. I'm almost done. I could get away, depending on the show, I could get away with saying I'm done here. And so you can see that it's natural, and sure, there's little areas where I might want to go in and fix it up. But it's a remarkably robust, and it just reduces the time that you're going to be spending painting weights when I should be making the tail do that cool thing that the director wants, or working on the face, or doing all of those other things. I'm really excited about this, and if you try it, I know that you will be too. Some other additions that we've added to the bone tool, and this is a small one, but it's a cool one. We call it bone divisions. You can determine, either on a parameter on the top there in the bones tool, or with the scroll wheel, the number of bones that you put down per click. So you want one bone, fine. Medial axis or interior snapping. So I'm using either the view to determine that plane, or I'm using the normal of the primitive. And I can draw bones right through the center of that finger, as you can see there. It's really great. And I should mention that these tools, here's a dog getting his ear rigged. So I'm using view state, or normal based here, and then I'm going to switch to view based. I should mention, though, that these snapping options are now available in the regular snapping tools. So one of the most common things that I've had to do in the past, you get geometry that was modeled elsewhere, and it's some kind of crazy vine system. And they say, okay, make that dynamic, make it do something. And you think, well, what am I going to do with this? Well, now you can draw a curve through the center of all those arbitrary vines or tree limbs or something. So these snapping options are now available just on the regular snapping tools. So let's talk about, let's talk about auto rigs. This is an auto rig system built completely in Python. It's modular, so you will be able to add your own module. You don't like our foot? Make your own foot. You need a character with wings for your show that has 50 characters with wings? Make a wing module You can put it into the auto rigs, and now you can rig those very, very quickly. You can save presets. It will build a capture network for you. The default supported biped, quadruped support is imminent. Has squash and stretch, noodle, so you can do like cartoony stuff, IK, FK matching, lots of bells and whistles. And it is really this simple. Here are my modules. Each of them has parameters and options that I can change, number of fingers, that kind of thing. I move these little guys around to determine where I need my joints to be. And the default guy is all set up really nicely. But then I am good. I click one button. Do I want to do this? Yes, I do. I'm done. I'm done. It is that fast. So, moving on. Constraint system, completely rewritten. We've removed all of the object constraints. So cameras, bones, nulls don't have that constraint section. It's all done in chops now. These are all built in Vex. We've added a chop wrangle for those of you who love wrangles. You can build your own constraint system. And this is just a simple look at. Wire this in. It's extremely fast, extremely fun to use. We've rewritten all of the shelf tools for those automated things, look-ats, stickies and rivets. They're all new, all in chops, and they're great fun. But those of you who are animators don't like to have stuff in your viewport. You don't like to find a control or go into a character picker and find the weird thing and click it, and now you can move it in the viewport. So we've introduced invisible rigs. You put an attribute on a primitive group, you assign that attribute to a control or one or more controls, and now you can just click and drag in the viewport. And if there's two overlapping, you get a dynamically built radial menu that will now give you a choice between those two, translate or rotate on an object, or the parameters of two different objects. So this is a lot of fun to use. It's very easy to set up. It's one SOP, and you just tell it what to do. It's amazing. Muscles. You want to draw a muscle on your character and have it rigged, have it dynamically animated. Now you can do it in Houdini 16. We have a jiggle, and then you can rig up each of those. You can see all the parameters there. You have full control in the viewport of their shape, the depth of them, their rigidity. And then sometimes you've drawn a bunch of muscles that you need to associate with each other. And so you can select a bunch of them, select their tools, I think is the next part, and then make what we call a Franken muscle with one click of a button, and they will be grouped into an FEM tetrahedral mesh and then deformed. All of these tools are, I think as Kristen has alluded to a couple of times, these are just steps in a road. These aren't tools that are one and done. These are steps on a road that is going to continue. Every update, we're going to bang away at character tools, and we're extremely excited for you to use them and give us feedback. And thank you very much, and enjoy rigging.
Thank you, Michael. Before you go, could you say tetrahedralize one more time?
Tetrahedralization. No. Sorry.
Aspialidocious. Okay, thanks, Michael. Yes. All right, guys. Hair and fur. So Kai Stavginsky.
Say that one more time.
Stavginsky. All right, another big project for us in Houdini 16. Just about a year or two ago, we tasked Kai with redoing the architecture for grooming, and he did a fine job. And then we decided, no, it's still partly a black box. This can't be, this is not Houdini, that's not who we are. So this year, we basically, rendering this thing, this is a first for us in Houdini. We don't have a fur procedural anymore. Mind you, you can write one if you want, but it's much better than that. Mantra actually uses the SOP network that you've written that you've put together as an artist to do the grooming. So as you're doing the groom, you're actually creating your fur procedural, so to say. And Mantra does the cooking of the node network, which is a SOP network, at render time, and it does so without taking a license. So it's basically free rendering with engine for hair and fur. In fact, it goes a little farther than that because you can render anything that way that is a curve or a point. So for sure there'll be grass, grassy things and other things that you'd want to take advantage of. But let's focus on hair and fur for now. So Kai, please do.
Thank you, and hello everybody. So before we get to the really juicy bits, let's start off with UI. You've seen some of this already in Scott's presentation. But basically the fur tools, we have a custom desktop that you can get to much more easily now. And it comes with a new set of shelves that just really nicely organize the new tools and the existing ones. And then we've got a custom radial menu. And one thing that I actually want to highlight here with the radial menu is the jump tools that you quickly jump around, like the parts of your groom, so like the guide curves and the hair generation. It's really perfect for that. It makes it so fast and easy to do that. But also to get to all the other tools. And then within that you actually have more specialized radial menus. So you can, like when you do your interactive brushing, you have a special radial menu that just has one level and has all those tools in place. Then the actual tools themselves, we went in and had a deep look at our existing tools, and we had this monolithic fur object that was kind of difficult to use. Now it's all broken into component parts, into simple modules, easy to use modules that all serve a single purpose, and each one just has a single editable network. It's very easy to manage. And the best thing about this sort of taking this apart is you can use it in any order. So here you sort of have this our standard pipeline where you just do your guide groom on a static character, then you deform it with the mesh that you get for your shot. You do some simulation and you do hair generation from that. But you can also swap it around. Like you can do some grooming first, then simulate and maybe freeze it on a frame, then do some more grooming, then deform that, and just do it in any order. Now jumping inside into these nodes, here you have what the guide groom and the hair generation looks like. And you'll notice it's exactly the same setup, except one doesn't have as many outputs, but it's basically the same workflow. And that's a huge advance from what we had previously. Before, you could do a lot of things with hair generation, but there were it was very powerful. But if you wanted to do something that wasn't pre-built, you had to take this huge leap. Like if there was something that you couldn't quite get to, you had to jump down to SideFX and get very, very technical. And now it's all the same tools, all SOPs. It's all just curves. So I'll show you some of the tools that we have. So you'll notice it's all just in SOPs, and I'm using the radial menus to create some of them here. Basically, the idea is we have a simple but powerful set of operators that you combine to then create very specific grooms. And we have this one node, like the central sort of node, the guide process, where you can layer a bunch of operations like I'm doing here, and then also very easily control where that operation takes place. So along the curve, or paint attributes on the skin very easily to define where everything happens. And then, of course, as you would expect, everything is live and procedural, and you can jump back and change parameters, and then those only take effect where you painted. So it's very easy to dial everything in and get a very specific look out of that quickly. And then jumping over to hair generation. You'll see it's exactly the same workflow. So I'm jumping over there. There are great architectural improvements in SOPs that make it possible to deal with this number of hairs very quickly. And we've got powerful tools there like the hair clump SOP that give you very natural results much more quickly than before. So you can concentrate more on getting the specific look that you're looking for rather than getting something that just looks good at all. And here we're just adding some frizz and some final layering. And you can get something quite good looking very fast, and it's exactly the same set of tools. And I just want to stress again, like if you render this now, And this is just a quick render of like an example clumping setup. And it's very, very easy to create this kind of stuff. And then dynamics. So dynamics are aware of clumping as well now. So you can see it's kind of subtle, but you can see a little bit here in the beard. Like it's these clumps that you set up at the grooming stage, the simulation is aware of that, so there are some extra constraints to keep those in place and preserve that so you don't lose like the carefully set up groom that you made. And here's just another example that takes it a bit further still. So there's curling that's also built into the clumping system, and it's all working through the simulation as well. And one more sort of technical nugget there is we've got this new sub to create a really clean like tangent space, so you don't get any flipping even when here it does fairly crazy things. And rendering this is just another example of the rendering pipeline. So again, this all uses the new sub workflow. Very, very, very flexible and powerful and easy to use. All right, that is perfect. Thank you.
Thank you, Kai. Next is LookDev. And most of you know that we have a long history with lighting and rendering for VFX. And Mantra, our renderer, has been used for rendering by VFX teams for decades. Also, maybe a little known fact that our rendering R&D have been acknowledged by the Academy of Motion Picture Arts and Sciences with a technical Oscar for innovations to volumetric rendering. So this is just one way of saying that we are very much committed to the back end of the CG pipe. So for Houdini 16, we did lots. We focused primarily on two areas of lighting and rendering. It's shader, the shading workflow, and then rendering, Mantra itself. We'll talk about big-time lighting next year, eh? But staying with Houdini 16 for now, the big push here was to simplify the shader building workflow. We've simplified it now so that it works entirely at the VOP level. You don't need to involve shops anymore, if you know what those are. And this comes with three great advantages. One, you can now do layering very easily with VOPs. And layering is a big piece of our goal for lighting and shading for Houdini 16. So much easier to do layering. The second one, much less hassle to maintain your shaders in the pipeline because you're not dealing with that dichotomy of VOPs and shops. And the third thing, which is equally important, anyone new to Houdini will have a much easier time understanding and adopting this workflow because it will feel familiar to them. Okay, so that was the main thing there. But on features themselves, we did a lot of work, and Kai was actually one of the big designers of that functionality to re-architect our shader modules with layering in mind, and also to be embedded much more easily into the principal shader, which now is a proper Uber shader with controls for subsurface scattering, which has also been redone for 16, dielectrics, and lots more. And finally, we have vastly improved the work on texture baking. We pay very good attention, I hope, to the needs of the gaming community these days as well. And this is one of those things that's truly essential for them. So we're really pleased with where we are on that. Thank you. And now back to Kai.
Thank you, Right, so with this one, I just want to start off with sort of new shading capabilities that we have. So one thing that's now built into the path tracer and supported by all our like Uber shaders and lower level components is absorption and dispersion that you see combined here. So absorption is, of course, responsible for the tinting in the glass, so that gets more intense as like for thick surfaces where the light has to travel through the object farther. And then we have the ability to split light into its component wavelengths that you see. That's what you see here in the like rainbow colors in there. And it's very easy to use, and it renders quite fast. Works really well. And then we have nested dielectrics. So that's the ability to, gives you the ability to model things where you have transparent surfaces in contact with one another, which is really difficult to do correctly without nested dielectrics. So this lets you just model these things with some overlap without like concern for getting the exact contact surfaces, and then the renderer basically does the work for you. So it'll resolve like where there's glass, there's no liquid. Where there's ice cubes, there's no liquid. And just render everything correctly. And even the rays get refracted with the correct relative index of refraction, and you get a very, very natural looking image very quickly. Then we have a new subsurface scattering model. So the focus there is, it's a very fast approximation, and it's integrated with the other lighting models that we have as a BSDF in VEX. So it doesn't have that. If you know Houdini, like you know that there used to be a separate path that you had to output the SSS, and now it supports all the standard lighting features like per component exports and all that stuff. And you get indirect lighting exposed through SSS as well, which wasn't possible before. Very fast to render now as well, improved efficiency there. And then, so all that stuff can be done now. So it's, the principal shader has a very, if you know it, like a very easy to use set of controls, but you can cover a much broader set of materials with that now. And then of course the big change, possibly the biggest change in shading is that all these shaders live in VOPs now. So there's literally no distinction anymore between these two, like the context where you build the shader and the context where you use it. And it's made possible by improvements to the network editor as well. So this is the new look of the VOP tiles that you see here. And you have these collapsible input groups that make it possible to make it convenient and possible to use nodes that have hundreds of inputs, which inevitably these Uber shaders tend to have. And then, of course, you get the ability to use those in a broader context of VOP nodes. So I can take something like the pre-built brick shader, principal shader with just these brick textures set up, and mud shader, mix them, and everything just happens intuitively and automatically. So you get the mix of surface and displacement shading very, very easily. And something I want to stress here is we sort of build a shader from that. So this is a combined shader now, but the component shaders that you use within that are precompiled and very, very fast. And that's you see that with that caching badge, that pink badge there, you see very quickly that these shaders are precompiled, so that'll work for your own shaders as well. So using this layering doesn't really make things much slower at all. And it automatically works for shader exports as well. So any exports that the shader has will be mixed as well and come out automatically as well. So that works through texture baking for games and everything. And then one amazing ability with this new workflow is you can grab any of these VOPs that you input into the shaders and assign them directly. So they're not really shaders, but we build a shader around them for you and figure out like which output is best to use as a visualization. And this is incredible for debugging shaders and seeing what happens in earlier stages of the shader. And as you can see, like it updates very quickly in the IPR. This shader building is automatic and very fast. And then beyond these pre-built Uber shaders, if you want to do something a little bit more custom, but you don't want to like write all your lighting code yourself and write your own BSDFs, we have a much more flexible and powerful set of lighting component nodes that support all these advanced new shading features as well. So if you go down to that level, you also get the ability to build your own shaders, slightly different shaders with all the absorption and dispersion and nested dielectrics built in as well. And it's also much easier to layer these now. So before you need to sort of know what happens there physically. Like if you have a diffuse reflection and a specular reflection, you need to know you need that Fresnel component to mix them properly and everything. And now the reflection node just has a base layer input. If you plug in the diffuse, it just handles the energy conservation and all that stuff automatically. So to build something like that, 2 nodes. And the same thing for something like a metallic base layer with a coat layer on top, works the same way. And then if you just need something more custom and a little bit unusual, it's also very easy to build that. So this is just an example where we have the refraction layer with nice absorption on the rough glass here, an emission layer on top, and then when you put the reflection on top, it feels like the emission is coming from within the object. It's like underneath the reflection layer. Also very easy to build that. And then here's just an example of the slide I showed previously, and this is a viewport screenshot. So we get much more accurate visualization of what our shipping shaders look like now. We've got real-time displacement there, code reflections, and much better support for transparency, which just uses the IOR directly. So that's a huge help with setting up scenes, and it's more than good enough. It's not 100%, of course, but it's more than good enough to dial in like shading values and do some look depth there. And then for your custom shaders, it's also much easier to make them work in the viewport. I think there used to be a tendency in the past, like most people didn't spend the time for their own like facility and show shaders to set up viewport visualization. I think that will actually change now because it's so easy to do, because you just take there's this concept of parameter tagging, where you take the parameters, the VEX parameters that you have anyway on that custom shader, and you just basically tell Houdini what function they have for the OpenGL visualization. So something like a color parameter, you just tag it with the diffuse, and then it shows up with whatever color you set there in the viewport. And that's how all our Uber shaders are set up as well. Then material style sheets, those are visible in the viewport now. That's a huge improvement to usability there. And then in the IPR, you've got this ability to click on pixels, and very quickly, however complex your style sheets are, you reveal anything that affects that pixel. So if you have these complex setups, it's very easy to drill down and find what's happening there and change values on those overrides. And then, as Kristen mentioned, texture baking has been improved hugely as well. I just have the single slide here, but I really want to stress it's a huge change. There's been a lot of progress during the beta still in the last few months, and we're really at a stage now where you get great outputs out of the box, and it works directly with standard game, especially game tool chains like Substance. So we have this example here where we have a procedural shader built in Substance, and the left uses the data bakes from Substance, and the right uses the bake from Houdini, and it basically looks the same. And we have really good edge and empty space interpolation there. So there are some empty spaces where you don't actually have any polygons in the UV space here. Those are interpolated really cleanly, so you get nice mid-maps out of that. Basically, it's supposed to just work, and it usually does. All right, that's look dev. Thank you.
Thank you, Kai. That was great. Thanks very much. I'm going to invite Scott back to the stage. And let's talk about fluids and oceans. This is vital Houdini territory. Everybody knows it. The bar has been set really high by us. And we intend to raise it every year. This year we have some really cool functionality added to our fluids. There's something called suction force, which is best to see. I'm not going to talk about it much. And then the big one is a re-architecture of the ocean toolset. If you remember a few minutes ago, I was saying how we took the grooming workflow and we opened up that box, no black boxing. And that's the same thing we wanted to do with oceans. We wanted to let you layer ocean spectra whichever way you want it. Add hero waves, do masking, be very artistic about the way you work with oceans and have that unlimited freedom in building the greatest complexity in the ocean look. And that's what we achieved with this release, and you'll be seeing that as well. Also, even better OpenCL support. We're now happy to say that our Pyro pipeline is fully OpenCL accelerated. And in fact, throughout Houdini, we've added lots more support for OpenCL. There's an OpenCL SOP and lots more, but that's outside this topic. I'll keep it short. Scott, please.
Thank you, Kristen. Are you still counting the new features? Because there's a lot more to come. So, yeah, as Kristen said, in a lot of ways we could have said like our ocean tools are good enough and then just support them and make them a little better each time, but that's not really the SideFX way. We stop and take a close look and say, well, there's a couple of things there we actually can improve quite a bit. So the first one is our viscosity solve. So we now can actually do a much better interpolation of collisions with these viscous fluids. So in certain cases, you used to get these sort of artifacts if things were sliding down a surface, especially if they were sort of at an angle like this. We now handle that interpolation much better. You get a much cleaner result. We've also added the ability to create what we call a slip field, which basically allows you to determine how sticky or slippery a collision object is for viscous fluid. So if you want to art direct something to make sure the mud comes off a character's eyes but still sticks to their face, you can do that very easily. But another sort of big new feature, and something that we actually did sort of have in the past, is this physically accurate surface tension. And so, we could do this previously, but it was sort of difficult to set up. It was unpredictable. Now this is basically a brand new version of this that allows you to do these very believable sort of macro scale effects where you zoom in on the single droplet to get this classic sort of crown splash effect that you see here. And this really opens up our fluid simulation tools for things that we weren't actually used that much for, these hyper close sort of product shots, commercial shots, things along those lines. And an interesting thing that happens with development at SideFX is somebody's building a tool like the surface tension, and partway through they realize, hey, by developing this tool, we've now opened up the ability to control something like the pressure of the fluid and get these interesting effects. And that's how we came up with this idea of a suction force. And so essentially what's happening here is this character that's walking through the water is acting like kind of like a vacuum. So as it moves through the water, water rushes in to fill up the space inside the monster. But what's interesting about this is that it's not just this sort of overriding of the fluid force. It's not just taking over. It still lets it behave exactly like fluid, just fluid that likes to stay in a certain area. And so you can see how it sloshes around inside the character, even spilling out and running down over the surface to create this really interesting, sort of unique looking effect that I think you guys are going to find awesome uses for in the future. And here's an example from Jason from Black Ginger, who was in our beta forum testing out the software and came up with this awesome sort of test scene of these crowd characters walking through this river and pulling up the water and creating these interesting sort of sloshing zombie-like characters. And so you can imagine now like how you can take these very physical, real simulations of fluid, and instead of overriding them completely to create a magical, interesting effect, you can actually work in concert with this completely artificial result, but still a very believable fluid simulation. And here's just another example, again, of something that you see a lot in commercial works and things like that. And now this time you can see that nice sort of rippling effect on the surface of this skull, this chocolate skull, where the fluid still stays alive, right? We're not just like constraining the position or something like that. It's still fully alive, fully able to form and flow around the object to create this interesting sort of surface. So coming out of all this research, we started to realize we could push around fluids in new and interesting ways that we couldn't before. And so a really cool effect was that we can now basically re-simulate parts of lower res simulations at higher resolutions, but keep all of the energy, all the forces from that low res sim in the high res. Even change the sim by adding a collision object that wasn't there before. And so on the left, that whole river is something like 2 million particles, and then the re-simmed version, that small slice, is around 12 million particles. So let's take a sort of a closer look at what's going on here. And the really interesting thing, the really important thing for a tool like this is that, we've substantially changed the flow of the water around this object. You can see how it creates these new eddies. But the inflow and the outflow of this section remains the same as it was in the low-res simulation, right? So if you imagine having a camera down by the water where you want a very high-res sim for the character to maybe walk through a river, and then a low-res background giant river that you could never do a huge simulation of. You could never get it high-res enough. You could create these two sections, blend them together, and then get a really nice, believable result without sort of having to kill yourself rendering billions and billions of particles. And then we took that same approach and we started applying it to simulations for oceans. So on the left, you're seeing our old wave layer tool. And this was designed to let you have basically an ocean surface and then some particles sitting on top of it so that you could run a boat through it, you could run an object through it and get a nice effect. But you'll see on the right, using our new guided ocean layer, which uses the same technology as the sort of resim that I just showed you, that not only does it match the ocean surface closer, so you more easily blend it into a surrounding ocean, but the motion itself is actually much more interesting, much more believable. The splashing, all of the boundary conditions are upheld. So again, this inflow and outflow of water is controllable. And so speaking of oceans, we basically reconstructed how we do ocean simulations to allow you to do things like this. So again, a guided simulation for the part where the ship is coming up out of the water, and then in the background, seamlessly blending together what we're sort of calling an infinite ocean, a non-tiling ocean built from ocean spectra. So let's take a look at how that works, because we've changed it quite a bit in Houdini 16. So we're going to look at an actual sort of walkthrough of how you might do it. So here's the network. Here's some ocean playing in the background. And essentially what we used to do is let you bake out these animations, and then you could have a shader that mixed the various textures together to create a result. So what we've done now is instead, we can actually let you sort of composite them together in SOPs. So you can take these two spectra, layer them together to get this new ocean. And you can see that now we've just mixed them together. So we have the high frequency small waves and the large frequency big waves. But then something interesting that we can do is we can actually draw a mask to blend between these two things. And if you look closely, I'm using something called a height field here to do this. We'll actually come back to that a little later when we talk about terrains. But the key option here is that I can actually just go ahead and draw a mask right in the viewport, mask out that piece of ocean, and then just set how much it's contributing to the overall feel of the ocean. And you can see now we get two completely separate oceans blending together. We can blur out the mask and get a nice patch of ocean here. And so this becomes really important when you're talking about art directing oceans, right? I need a nice still patch here close to the camera. I need a rough ocean coming in from a storm or something like that. And so we didn't really stop there. We wanted to take this even further. So not only do you layer these spectra together and create interesting oceans, but you can now instance ocean waves on patches. So essentially what I'm doing is creating a point cloud, and for each one of those points, we're going to put a random patch of ocean and blend them together. And so you can see if I reduce the radius that each patch is getting a sort of a unique piece of that ocean spectrum. And you can do interesting things like offset them in time, offset their rotation. But what this means is that you can now take those multiple spectra, split out the points for each one, and now create giant, unending ocean surfaces, because really all you're creating is a point cloud with a bunch of information on it. So here we've mixed two separate ocean spectra together, and we're just blending them together using this radius parameter. And now you get this, the ability to create these really large-scale oceans that really wasn't possible before. You always had to fight against tiling artifacts and repeating. Now we've completely eliminated that from the process. And another interesting thing about being able to use points to put pieces of ocean into a simulation is that we can now create what we're sort of calling a hero wave. So the lines that you see in the top left there, they all, again, just have specific points with a piece of ocean on it. But what we've actually done is sort of frozen the ocean to a specific wave. So you can say, I want this kind of a wave on this point, and then essentially hand animate your wave. So you imagine, you're trying to time a shot where, we need a very large wave to come in and hit a boat at a very specific time. Now you can do that. And of course, all of these ocean spectra, all this stuff I'm showing you, still feeds into the flip simulations. So that guided surface I showed you earlier can use all of this functionality. So you can blend your sim into this entire surrounding ocean. So here's just a video just giving you an example how we layer up these patches of oceans using these points to create a much more believable ocean with no tiling artifacts and these little interesting areas where wind has sort of picked up certain areas of the ocean and other areas stay nice and smooth. And then just a nice sort of final render just so you can see how it all comes together to create this really great ocean. I think this one is like 8 kilometers of ocean or something like that. So it's a very large patch, very difficult to do in the old ways using baked textures. But we haven't removed that. You can actually even bake the multiple spectras to textures if you want to. And just to end off here, I also want to point out that because we've moved to this sort of point cloud approach, that means you can actually put oceans on arbitrary surfaces. So you're no longer constrained to a grid or writing a custom shader in order to create these fluid effects on non-ocean surfaces. You can do something like this twisted ocean where we basically have deformed this curve into this shape, and we're still able to just instance the waves across it, so you get a nice consistent ocean spiral coming down into the darkness there. So again, we've basically, we've really improved the flip solver itself, but then we're supporting that completely with basically a completely overhauled workflow for our ocean surfaces. So again, I hope you have a lot of fun with it, and thank you very much.
Thank you, Scott. We have one more project to talk about today, and that's terrain generation. Now, we all know, and many of you, in fact, have been working on terrain tools for your studio for a long time. It's been happening for decades, and we've helped many of you achieve that result. I remember some years ago I was in LA, and every studio I visited said, how about terrains, Kristen? So more recently, their voice has been amplified by the needs of game studios, and there goes even greater scalability, even bigger need for something procedural. So for Houdini 16, we decided to tap into all that knowledge that we built, helping people out, like I said, over decades, and we zeroed in on terrain generation as an actual architecture to put together with tools designed on top of it, of course. So us being who we are, we decided to take a different approach than the standard or typical one of using image compositing for height fields. We actually thought of staying in SOPs, doing everything in SOPs, and using our volume capabilities in SOPs. That's not OpenBDB, guys. These are our own volume data types that we've had around for some time. But these are 2D volumes, slices, so 2.5D volumes. They're extremely fast, so don't think slow. Plus, even our volume data types are not exactly dense as people think. There's a lot of partial sparseness to them as well. Anyway, so we're basically doing it all in SOPs. We're compositing SOPs, layering all these operations to generate terrain using noise and all kinds of tools. All of this is not only procedural, it's art directable. And again, the whole idea of no black box, same thing that you saw with Oceans just now and earlier from Kai on grooming. So that openness and flexibility and usability all come together and gel into a very powerful architecture. And then there's more. I mean, you'll see all the details from Scott, but very important to mention at the end of this is the fact that inputs and outputs that are needed by game studios and film studios as well and others was something that we need to focus on. So we support all kinds of LiDAR formats to go in, and we can output geometry and native formats into game engines and other apps as well. And rendering is pretty fast with Mantra, but you can always generate the geometry, the surface, and render in every other package. And talking about that, the other advantage to doing this all in SOPs is that you have immediate access to the entire arsenal of modeling tools in Houdini, because this is all SOPs. So if you've built your height fields, then you can add all the concavities you need, build all the caves and rocks and all those shards that you need very easily in the same context. Anyway, enough talk. Let's take a look. Thank you.
So this is truly brand new. We've never had these tools before in Houdini. So we're actually going to spend some time in Houdini taking a look at how you actually would work with these tools as sort of a more proper introduction rather than the very high-level stuff. So let's take a look here. So first of all, we're starting with a height field. You can see I'm using some of the radial menus there just to get started. But essentially what we're doing is we're creating some noise and we're deforming this patch of volume. And basically we're displaying it as a displaced surface, but it's really these 2D volumes that Kristen was talking about. But you can see here that really we are truly compositing these. We're building layers of noises. We're adding them together in interesting ways. And then we're just going to start blending them. And we can do that, much like I did with the oceans, by drawing on one of these masks. And what this allows you to do is, again, much like compositing, blend these together to create different types of effects. So we've isolated a specific patch of noise we want to do. In this case, we're doing a maximum between the two to create this sort of little hill in the middle. And so really the idea is that you just work with these pieces, you combine them in interesting ways. So here's an example where I've just used this whirly noise, this kind of cellular noise, and I'm just going to isolate out something that looks like a sort of a mountain peak. So you can see I just found an interesting piece. I'm just going to blend that out to nothing. And then using tools that you're already familiar with, things like transform SOPs, things that you know from SOPs from other contexts, I can just place that mountain range anywhere that I want. So again, we're giving you the procedural, powerful tools to create the noises, do the distortions to make it look organic. But of course, you always want to art direct these things, right? You don't want everything controlled for you. So we can let you put down a mountain, copy it, move another one around, place it exactly where the director asked for, exactly where you need it for your particular shot. And again, completely procedural from start to finish. So completely art directable, but also changeable up to the last second. And so here's just the result that we get just from those handful of operations. You can already see, this is starting to look like a fairly believable landscape. In fact, put that in a far background, you could probably get away with just doing this. But of course, we don't want to stop with just like a couple of noise tools and a couple of deformers. We want to add tools specifically for terrain. So here now we're going to talk about some tools that we've built, things like this terracing node. And this again allows you to create the types of things you see on actual terrains when the layers of strata sort of break apart. And again, mask out an area. You can see how interactive this is, partially due to how we're using OpenCL to make this very fast in the viewport. Here we're just clipping off some of these mountains to create more of a desert sort of mesa effect. And then we also have this way of creating patterns, things like these star shapes, these weird zigzags. And you're probably looking at it and go like, I don't see how this matches a terrain. Like these are very odd shapes, non-organic at all. If we combine them together, we get this odd sort of stair step, which makes some sense maybe, but not really. So, of course you want to distort that then. You create sort of mesa creation. And again, just to give you an overview of what this looks like now, just in the viewport here, of how much detail we can get into it. And that's another important thing is that because this is all procedural from start to finish, you can actually work at low res, work at 60 frames per second in your viewport. And then when you're happy with the result, just change your input to be a very high resolution height field. And now you get a very high resolution detailed result. And so Kristen was saying, we wanted to bring this all into SOPs. But really, if all we're talking about is compositing, why bother? But this is why. You can take in something like this beautiful piece of geometry that we have and bring that right in to a height field. So you can use SOPs, you can use modeling SOPs, you can use geometry as inputs to height fields. And then continue to work on them as if they were always height fields. So add noise just to this sort of pig head. Blur the edges, make it look more organic. And so now you can really sculpt right down to exactly the shape you want. It's completely art directable. But the reality is we haven't abandoned actual compositing either. So here we are in the terrain desktop. So I've opened up the compositing window. I'm going to put down a node where I can call a node from compositing and use it inside my height field. So here now you can see this sort of pentagon shape being extruded in the height field. I can change the number of sides and it updates the height field at the same time. And then I can use it to sort of cut a hole into our landscape here. And then as I work inside of COPS, inside of compositing, I can do blurs, I can do compositing effects, and have them update live inside the terrain tools. So really all of this is about taking all of the tools that you're familiar with and sort of integrating them together so that as you learn one part of the software, you're already learning another part. And you're pulling it all together to create effects that aren't possible if we isolated these into their own sort of black box architectures. And just to really drive that home, let's take a look at how we can take this landscape now, and instead of doing the operations that we did before, let's take an input from outside that you really wouldn't expect to be part of a landscape. So here we have the ocean tools that I showed you earlier. Here's an ocean evaluate, the exact network I had before. But the interesting thing is that we can output a height field from an ocean. So now this is a height field. It's a 2D volume. And that means I can do height field operations on it, like create these distortions. I can add noise. So I can actually use ocean tools, things that have nothing to do with landscapes, to create really interesting looking landscapes, things like desert dunes, things that are difficult to do, and getting these really awesome natural looking rippling effects that tie directly into the ocean toolset. And then, of course, if you want to, you can convert the height field into geometry. You could run a boolean operation on it. So again, we want to be able to go from one context to another seamlessly, as if there's no difference between these tools. And in fact, really, there is no difference between these tools other than the specific piece of data that they operate on. And just to end off here, since I'm talking about converting things into geometry and using oceans and so on, I want to point out that we can also run simulations on these tools, right? So let's start first by taking a look at some examples that come with the shelf tools. We have something we call terrain effects, where we're really just examples of different types of terrains to get you started, figure out how the tools work. You know, we have a mountain, a valley, and so on. But really, to make this look truly believable, you want to run a simulation over it. And so in that case, we have a new type of simulation that simulates erosion on height fields. And so basically, you can take those sort of very interesting looking, but not super realistic terrains, and run a simulation to discover where does the water go, when it flows over the surface, where does it collect, how does it pull debris from one part of the terrain to the other to create valleys and so on. And again, this is very fast, all running on OpenCL, and so allows you to experiment, to iterate, and create lots of different types of landscapes very, very quickly. And of course, like all other parts of Houdini simulation tools, you can get interesting data out of it, right? We're not just giving it this black box. So I can find the flow, like where have things moved, how quickly have they moved there? Where is the water, how does it collect in certain areas? And then you can take those different layers and build a shader from them. So this is actually a viewport rendering of the landscape with various texture maps and shaders applied to give it this mountainous look. But we also have a terrain shader that basically is the equivalent of the viewport, allowing you to take any of these layers, bring them into your shader, and build a custom landscape using those. And of course, you know, Houdini is known for effects, so the background that you see here that the crowd agents and the RBDs are traveling across, that's a height field object. And what I mean by that is that we haven't converted it into something else. It's natively a height field inside of DOPS. So you can create your landscape and use it as a collision simulation directly. Oops. This video appears to be messed up, but imagine an incredible looking avalanche. Just like unbelievable. It's in there. We're in the process of keying it out. That's why it looks like this. But trust me, it runs over the landscape, it collides with the height field, it looks great. And so just to end off, especially because Kristen was talking about exporting it to different places, here we have a Houdini generated landscape inside of Unreal. So the important aspect here is that all of the data that we're creating can be exported in a very game engine friendly way. We can also have tools for breaking it up into tiles, so you can work on enormous terrains, slice them up into smaller tiles, and work on each one individually. And of course, all of the tools that you would expect from SOPs to work with landscapes like scatter and so on for placing your vegetation work as well. So it's fun to end off here with this really awesome result using Unreal Engine and our terrains. And I hope you guys really dig in and play around with these tools, because they're all new, but they're a lot of fun, and you get really great results very quickly. So that's terrains, and thank you very much.
Thank you, Scott. Thank you, Scott. I think you're Mount Pigmore looks better. The list of features in Houdini 16 continues. It really could go longer than this, and there are a couple of wonderful gems in there. Can you spot the compiled SOPs? Anyone? We don't have time today to visit them all, but we'll have lots of tutorials and master classes ready for when Houdini releases on February 21st, so 2 more weeks. So please bear with us as we add the final touches to the software. We have some more docs to write. And like I said, these master classes and tutorials are being worked on as we speak. So 2 more weeks, and it's there. Thank you very much. We've had a terrific time presenting to you today. It's been a blast working on Houdini 16. Hopefully it shows, and we can hope that you'll have at least as much fun using it as we did putting it here for you today. Thank you. Thank you. And to take us home, here is Chris Aber.
Thanks, Kristen. And thank you, everybody, for making it out this evening, whether you're here in person or on the web, but certainly in person, because it was cold and rainy, and I know not pleasant to get here. So we really appreciate you making it out. As the director of marketing, one of my key roles is to help tell the story of Houdini, both from the inside out, but also from the outside in, and also from the outside. Just helping build the community and pull the community together and help to facilitate conversations with whether it's webinars or tutorials, master classes, events like this one, and it's a real pleasure. So I'm glad that you all made it here this evening, and that you continue to be such a great community for Houdini. Give yourselves a hand. Also want to say a special thanks to the people that came from out of town. I know there are quite a few, so thank you guys. And the recording will be available online. There were a few hiccups on the web, and the recording will be seamless when you look at it later on. So the internet here wasn't perfect, but it'll certainly be good online when you see the recording later. After this is over, the people that are in the cinema, we're going to have you come into the mezzanine, and you can hang out there while we clean out the chairs down here, and then basically the whole place will be available for hanging around. Upstairs we have demo pods, 5 of them, maybe 4, I think. Oh, no, we have 5. We fixed the TV. And each one will have a product expert at it. So there'll be rigging for grooming, terrains, et cetera, modeling. And each one will have an expert at it. So feel free to ask questions, and I'm sure they'll do their best at answering those. The social goes until 11:30 this evening, and I think that's it for now. Enjoy.